Okay. Let's take a look, okay? So, what we've been working on, if we go back in and we look at our success criteria, we're supposed to be finding the radius of convergence, which we did on Friday, and then the actual interval of convergence we sort of touched on, but we didn't quite finish because there's an extra catch to it, okay? It's possible that one of the endpoints is not included in the interval, okay? Meaning I have to determine if the actual endpoint converges or diverges. So first I have to determine the convergence of the series, okay, using my ratio test. Then once I get those endpoints, I have to plug them into the series and use one of my other tests to determine if that specific endpoint converges or diverges. So this is not short, okay? I apologize for it being a Monday, but it is what it is. Did I give you guys more space in here? Is there like a page a problem? Yeah. Okay, good. That's a good thing. That was way more than what I did in previous years. So, all right, so we're finding the interval of convergence for the power series. That's the instructions. That's all we're going to do today. We're going to do 3 of these, hopefully. Okay. So I'm going to always start with which test? What did we just say? What test did we use last week? Ratio test, right? Every single time, this is going to start with the ratio test, okay? Because I can force a ratio test's interval of convergence, and I know when it converges absolutely, okay? So I am going to start, the ratio test, remember, starts with the limit as n approaches what number? Infinity, good, okay? And then I have to plug in what? N plus 1. So if you didn't get ratio test before, you certainly will after today's lesson, hopefully, because we're going to do it a bunch of times, okay? I have to divide by the original, or I have to multiply by its what? Reciprocal. So I'm going to go n over x to the n. Okay. All right. I'm going to split that up and do my canceling stuff, right? So limit as n approaches infinity. What does x to the n turn into, or x to the n plus 1 turn into?
Oh, x to the n and x to the what?
Yep. And then I still have times n, right? All over n plus 1 times x to the n. I could write those as separate if I wanted. It doesn't matter. I chose to put them together. All right, what cancels? That's it. Okay. So if I look at what's left, and I'm going to rearrange it a little bit. Okay, I know I've got this x. Because if you did that, you'd be killing kittens. Okay, let's not kill the kittens so close to Thanksgiving and Christmas. It's okay. All right, so all I did was rewrite a little bit, right? So we've got n over n plus 1. Remember that when we're plugging in, we're only plugging into the n variable. I'm ignoring the x. I'm treating it like a coefficient. Yes, it's indeterminate. So either I could do L'Hopital's rule, or couldn't I look at the exponents? What are my exponents on there, both? 1, so I'd look at the ratio in front. What's my ratio in front? 1, okay? So what's left behind out of this thing is that I get the absolute value of just x. Because remember, my limit was on the n, not on the x. So the x stays like it's a coefficient, okay? Ratio test says that I converge if I am less than what number? 1. We did that on Friday. Okay, so same pattern. Ratio test, plug in the n plus 1s. Then we're going to do the ratio test, set it less than 1. Okay? All right, now I'm going to find my interval. Okay? And I'm going to, I could calculate the radius out of it too if I really wanted to. All right, so my interval, I'm going to split this up into a positive and a what? Negative. So I go, I basically sandwich it, right? -1, less than x, less than 1. It didn't ask me for this, but let's talk about this because we talked about it on Friday. How big is the radius? The radius is 1, right? Because I'd have to go from the center out to one of those values, so it's 1. Okay? All right, here's the catch. I don't know if those endpoints are included or not in the actual interval, and I have to test that, okay? So that might not be my complete interval. One of them might be included. They might not be included. Who knows? So what I'm going to do now is I'm going to put these endpoints into my original, okay, and do whatever, all my series tests on them, okay, and determine if it converges or diverges at the endpoint, okay. So I am going to look at when x equals -1. So I'm going to put -1 into our series here. So it'd be the sum as n equals 1 to infinity, I'm going to zoom back in, of -1 to the n over n Okay, you guys know this stuff. We haven't done it in like a week or so. Okay, but you know it. You had to memorize it. What test are we going to use?
Alternate.
Why alternating?
Because
There's a -1. Okay, so I'm going to go alternating. Okay. All right, so alternating starts with the limit as n approaches infinity of my series, but I ignore the negative, right? So 1 over n. When I put infinity into that thing, what am I going to get? 0. Is that what we wanted?
Yes.
Yep, so condition 1 met. Condition 2 says the terms have to decrease, right, on an alternating. So I'm going to start putting in some terms. So I get 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. And so remember, I'm plugging into this, ignoring the negative. Are my terms decreasing?
Sweet.
Yes.
Why? I have a question.
Uh-huh.
Why does it say when? Never mind. I was looking at when x equals -.
I'm just showing you that I'm testing this endpoint.
But we're doing n equals 1.
No, we're doing when x equals -1, because remember my original series was x to the n over n. So we're plugging a value in for x. Okay? All right, so what happens with this then? Does it converge or diverge? Therefore converges, okay, by alternating series, right? Which we can abbreviate AST. So how we adjust what we have here is because that one converged by alternating series, -1 is included in the actual interval of convergence. So we go back and we write an equal sign under it. Okay. All right. We're now going to look at the other endpoint. So when n is less than 1, or sorry, not less than 1, equal to 1. My brain was not functioning there for a second. All right, so I'm going to use the same thing. We're plugging in for that x. Instead of plugging in a -1, we're plugging in a +1. What's 1 to any power? 1. Oh, it's harmonic. What do we know about harmonic? So we could just simply write diverges by harmonic, right? So do I get to add an equal sign to my interval? No, I'm just going to leave it as no equals, okay? This right here, you guys, I've seen this more recently pop up on the free response, okay? So ratio test is going to be on the free response, and this is a possibility of how to apply the ratio test right here, okay, is this interval stuff, okay? Any questions?
Do we have to write like a concluding sentence?
Nope. They're going to just ask you what your interval is, and you're just going to have that listed, okay? Any other questions or concerns? You might want to write that down at the bottom. I didn't because where I landed.
Is
But
this just gonna, like, the whole unit 10, the other half of it, is it just gonna be, like, consistency for us to get it?
what do you mean consistency?
Like, keep doing always to solve it?
Isn't it always?
No.
Okay.
Some of it's easier.
Huh?
Some of it's easier.
Some of it's easier, some of it's harder, right? And then this one's been kind of sporadic. It's like one day is super easy, one day is hard. One day is super easy, one day is hard. Okay? We're going to reinforce tomorrow's is, like, we did Taylor-Maclaurin polynomials. Tomorrow we turn them into series. So there's another layer to it tomorrow. Okay? Because I know some of us are struggling with the polynomial piece. We'll get there. Okay? All right. We're still finding the interval of convergence. For the power series, that one looks a little uglier than the previous one. Let's see. So what test am I supposed to apply immediately?
Geometry.
ratio test. We start with the ratio test, right? What do I have to plug in first for the ratio test? N plus 1. Do I need to worry about this negative 1 to the n? No, because we're going to put absolute value bars around it, so it's going to go away. Okay, so we're going to start with the limit as what? Good. So we've got x to the 1, x plus 1 to the n plus 1 over 2 to the n plus 1. Okay? And then I'm going to divide by the original or multiply by the what? Reciprocal. So 2 to the n over x plus 1 to the n. Okay, here's what I want you to do. You should be able to expand it and cancel, right? Do that part. Try to get it less than 1. Okay, and if you get that far by the time I say, hey, let's check it together, see if you can get at least the interval. Don't worry about doing the tests and plugging in. At least try to get to your interval piece, just like we did on the last one. Okay? Remember, you set it less than 1 once you've got it simplified. All right, give you about 30 more seconds. Get as far as you can. Okay, I did my expansion. Do we agree? We good? I mean, do I need to explain it to anybody? All right, I'm going to cross some stuff out. What do I get to cross out? 2n. Okay, so what I am left with is the limit as n approaches infinity of the absolute value of x plus 1 over 2? Yeah. Okay. So, is there anywhere for me to plug my n into? No. So my limit is what's inside of there, right? The x plus 1 over 2, and I'm going to force that to be less than 1. Okay, if you got that far, great. Okay, if you got a little further, even better. All right, so in order to split that up, what do I have to do?
-1, and then x plus 1 over 2 to 1.
Yep. Remember, when you're solving this piece, you have to treat it like it's two equations. Whatever I do I have to do it to the less than and to the greater than side. Okay? So, what am I supposed to do with the 2 to get the x isolated? Multiply. So both of them are going to go -2, and then this one's going to be +2. Okay, what am I going to do with the 1? Subtract. So what's -2 minus 1? -3. And then 2 minus 1? 1. It didn't ask us, but if they asked us for radius, what would it be? It'd be 2, right? Because isn't the whole length 4? Right? -3 to 1 is 4. Halfway would be 2. Okay? Does that make sense? All right, I still need to test my endpoints, and this is the part that just makes it like the never-ending problem, right? I'm testing I made it way worse than it was. I'm going to test the endpoints, okay? All right, so I'm going to start by testing when x equals -3, okay? So I'm taking this thing here that was originally there, and I am plugging -3 in for the x. Okay? So I have the sum as n equals 0 to infinity, not 1, but 0 to infinity, of -1 to the n, -3 plus 1 to the n over 2 to the n. It could be, yeah. Let's simplify a little bit before I go alternating series, okay? So, what's -3 plus 1? -2, good. So it'd be -2 to the n over 2 to the n. What almost cancels? The 2's, right? Could I rewrite this so it would cancel? So it would be -1 to the n, -1 to the n, 2 to the n. Right? All I did was tear this part apart. Okay. What happens with the 2 to the n's? They cancel. Okay. All right. So what I have left is, what did I happen? I left it to the n. I'm looking at what it was there. It wouldn't matter though. Okay. So if I try to do, I have, let me put what I have left. N equals 0 to infinity of -1 to the n times -1 to the n, right? No matter what I do, okay, and I put infinity in there, what am I going to get? I'm not going to get infinity. It would either be plus or minus 1 somehow, right? Wouldn't it? Because 1 to any power is itself, right? And we don't know if on an infinity it's going to be positive or negative, right? So 1 to any power is itself. All right, so I get plus or minus 1. Either way, whether I put infinity in or whether I put 1 in, what is it not equal? Isn't this an nth term test? So if I don't equal 0 on an nth term test, okay, it diverges. So this one diverges. So do I get to put the equal sign for the -3? Nope. I keep the -3, no equal sign. Unfortunately, we're not done because we still have to test the 1. See, it's not pleasant. It's tedious today, right? That's the part that's the pain, is it's tedious. Okay? There's a lot of steps. All right. We're going to put in, what number am I putting in now? I'm putting in 1. So I'm going to test 1. So when n equals 1, I'm going to go into the same thing. Could I skip a step and do the 1 plus 1 in my head? Yeah, I'm going to do that. Okay, so we've got the sum as n equals 0.
X equals 1?
Yes, it's x. Thank you. It's x equals 1, not n equals 1. Okay, so it'd be -1 to the n. And then we said it would be 1 plus 1 is 2 to the n over 2 to the n. Oh, it's nicer this time. What happens? It cancels right away, doesn't it? And then I have the sum as n equals 0 to infinity of -1 to the n. What test? Yeah, let's do nth term again. So limit as n approaches infinity of -1 to the n, which is going to be plus or minus 1, which is not 0. I totally did not do the limit out in front of this one here. I went to the nth term test. I did some really bad notation there. All right, so what happens by nth term? Diverges. So do I get to write an equal sign? We did all that work and we didn't even get any equal signs. Isn't that great? Here's the thing. If you didn't test it, you would have gotten lucky, right? But if you didn't test it, for sure one of them would have had to have been an equal sign. Okay? You want to make sure you can prove it. Okay? Good news. There's only one more for us today. Isn't that exciting? Is there anything, did I leave anything? Oh, I did leave this stuff in there. We're not going to do that stuff, I don't think. Oh, what's this? What else did I leave in there? Intervals of convergence. I'm not going to mess with that. All right. We're not going to mess with the other stuff. We're just going to do this last one and call it good, okay? So we're going to do example 3c. Okay? I don't know if I did any of the other stuff in previous years. No, I left it out. Okay. All right, let's take a look. Okay. So I'm going to give you like 3 minutes. Okay, this one doesn't look so bad. Okay. I will tell you the 2 tests on the endpoints are really nice. Okay, so I'm going to give you 2-3 minutes. I want you to try on your own, see if you can get to the endpoint tests on your own. Okay, so I'm going to give you a shot on your own. Take a couple minutes. Try it out. Start with ratio. If you're ready and you want to talk to somebody about it, talk to your table. We'll start in about, I don't know, a minute. Okay, let's take a look. I got it set up. Does anybody have any questions on the ratio test piece that I put up there? I plugged in my n+1s. I expanded. I simplified. I haven't quite done my limit yet. What do we notice about the exponents on the limit? They're the same, so I get the coefficient in front. What's my coefficient in front going to be? 1, which just leaves the x, right? So it's going to be absolute value of x, and I have to force that to be less than what number? 1. Oh.
I did something wrong, but I still got one.
No, I still got one too. I just left it at x over 1 squared.
Yeah.
X over 1
Squared.
squared.
We probably expanded.
Maybe, did you do something weird with your n squareds?
I put n squared plus 1 squared.
Yeah, I did that.
I expanded.
Okay, so you guys were treating it like a factorial. Don't treat it like a factorial. Okay?
Still got one?
Yeah, we still got 1.
I understand you still got 1. Here's the thing. That's fine here, but when we go see, so when College Board goes to grade that, they will actually look at all the steps. Okay, so you want to make sure your steps are correct. Okay? All right. I know this is the one where I had to grade it. So I graded like 900 of these, at least. So, all right. We are going to split that into what and what? -1 and +1, right? So I don't have to worry about doing any more algebra there. Okay, I just get to plug in. So I'm now plugging in when x equals -1, which would be the sum as n equals 1 to infinity of -1 to the n over n squared. So what test am I going to do? Alternating on the first one, right? Because it's a negative. So limit as n approaches infinity is our first step, right? Of 1 over n squared, which is going to equal what? 0. So that's good, right? Because we're doing alternating. And then I have to check and make sure my terms decrease. My first number in would be 1. So 1 squared is 1. What's 2 squared?
4.
And what's 3 squared? So are we decreasing? Yep. So therefore it what? Converges by AST or alternating series test. So what do I get to do with the inequality? Add an equal sign. Okay. All right, we got to do the other endpoint, which is a +1. So I'm going the sum as n equals 1 to infinity of 1 to the n over n squared. What's 1 to the n? 1. And this one is what series? P series. We like P series. P is equal to what? 2, which is greater than 1, which means that it, look at that, it drew an arrow for me. It converges. So what do I do to the equal sign? Or what do I do to the inequality? Add an equal signs. That one would seem to be worth it, right? Because we got equal signs on both of them. They're both included in the interval. Okay? Are there any questions? All right. Thank you guys for sticking with it. I will make sure that, I don't know if the homework's out there or not yet, but I will make sure it's out there so you guys can practice a little bit. Okay? Make sure you are practicing because you don't want to just not practice and then try to do it on the study guide and then you don't have enough muscle memory in your